The next video is about 3D printing, 3D designing. You see, the design that I have now is the complete ESP is in a sealed housing of plexiglass. And plexiglass is very good. It can be almost cold welded, they call it. That means that the seam is as strong as the material. You see, this one is a very nice one. You see, it's also crystal clear. Yeah, you see here some air gaps. And you see the inner life here. So this one is made out of, first I have here, this is laser cut out of 50mm thick PMMA. You see, this laser cutting is amazing. It is a very, very small gap. That means it's very precise and it's affordable. So and then this is also PMI sheet. This is 2mm thickness, and then you can easily glue this together. Then all the electronics go in and you glue the top. And then with the router you can get this nice result. Now to mount this on your arm or on your boom, I made a 3D print. It fits in it, and it has here some holes where I put in then a 3mm rod. And then you had something like this here. This one is with a very short elastic band. It fits your boom. So the text is done with I have a Bambulab P2S printer with 4 wheels that switch automatic. So during printing it's automatic that it uses another filament. This here is my printer. I bought it recently. I'm very happy with it. I'm very impressed with how good it works actually. It is really plug it in and print your parts. Here I have a black one with a longer elastic band, so this fits around your arm. You know, another one. On off is still with the magnet. So yep. By this one you see here the window is not on the exact position. I have to print here a new one with the window a little bit more to the left. From material cost it's really almost nothing. I think here there's something like maybe 30 grams of filament in it. It means the cost of the filament is less than €1. But you see here the reed switches is beneath the print. This here is our 3D model that is made in Onshape. Onshape is a very powerful CAD program, and you can use it free, but your designs will be public. So this design is public, it's accessible for everyone. I will give you the link down in the description of the video. Here is the PMMA housing part of it. So there's also top and the bottom. And interesting about this program is in the 3D model that these variables can change and everything goes with it. So I say I want my case a little bit higher, larger, and I change this dimension, directly everything changes with it. So this is really a very nice feature. I'm gonna set it back here. 40. Now I'm gonna write the top and the bottom again. So if we want to order this with a laser cutted part, we need a DXF drawing of this contour. So I go here for not in the assembly but in the part studio. So then I need carefully to get this sketch, and then when I have chosen this, I can right click and export as DXF. That's all. I export it, and now I have the DXF of this contour. So when you order it, just send the DXF and then they cut it to that specification. Okay, I go back to assembly here. I make isometric. So let's see the top, see the bottom. It's already the casing in the bottom. Right this here. So that's the casing that I made. So I'm gonna write. Now we only see the casing. Now you see it's rather simple part. Then I print it in PETG because PLA is not good for outdoors and for water resistance. PETG is perfect. Also here, we want to change some dimensions. Let's say we want here the case wall. I have a case wall of 2.5 millimeters. I want the case wall of 5 millimeters. Enter it. And then paste it. The thick wall. So easy is it. Okay, set it back. What I need now, this window should be a little bit more to the left. And that is this here, offset. Make one with offset 7.5. Now my window is 1 millimeter more to the left. 8 millimeters. Okay. So if you want to 3D print this model now, that is very easy. I just go here, I right click on the casing, export, I give it the name that you want, ESP casing. Offset. Format STL, units millimeters, resolution fine, export. So simple is it. Okay. Now take a look. I open Bambulab Studio now, and now I'm gonna start with the project. First, I add the EL file. There it is. Make it a little bit bigger. And now important, if we want to add some text to it, a different color, we first choose the part, text, and then I'm gonna here 10 millimeter height, and then here I'm gonna make the text in the part. That means embedded about 1 millimeter, and here adapt. And can we print it in another color? So I move it over here and with them bold. Then I'll do ESP. Version 6. Okay, remove it a little bit here. Okay, that's that. Then we're gonna add some other text. Wait, first to the part, and then control this one here. Make this one a little smaller. Wait. Do some bold, just straight. Okay. Also adapt. Now here we go to objects. Here, casing, we're gonna do in material number 1, patchy black. And here, text shape, I'm gonna do it in material number 2. So here, material number 2. The text will be yellow. And what I always do for this part, I need a little bit more strength. So the filling, set on 20%. And the walls, these are the outer walls. I'll set it to 5. Okay. Now we're gonna try slice it. And directly an error because you first have to turn around the part. Okay. So what we're gonna do here, and this is auto. And it will be upside down, which is much better for printing because we don't need any supports then. Again, let's slide. Okay, it worked. Well, we can check what will be printed here. And now, after splicing, you go to print. And I can send it, and it will start to print. It will take about 1 hour. Only 25 grams of material. You know that 1 kilogram, around 15 to 20 euros. Peanuts, huh? The material. Let's do this. Okay, start. After an hour, the print is ready. And to remove it, we take the build plate and then here it is. Let's see if the window is better fit now. No, not enough yet.